Hey everyone, welcome back to the Tutoring Hub. In today's video, we will be talking about scalar multiplication of matrices. So each element in the pair of brackets is multiplied by the scalar multiplication or the constant. Given that A is equal to A, B, C, D, then K, which is in this case our scalar multiplication or constant, times A is equal to K times the matrix or the matrix times K, and that is just us multiplying the constant by each element inside of the matrix. Therefore, you would get KA, K times A, K times B, K times C, and K times B. Let me also point out that the dimension does not change. So let's go right ahead and start working some problems. So first problem, given that B is equal to negative 10, 14, 1, 2, negative 3, 0, 0, 7, 10, calculate 4B. So our constant or our scalar multiplication is 4. So all we'll be doing is multiplying 4 by each element in our matrix B. So 4B is equal to 4 times our matrix, which is, so as we said, we're just going to multiply 4 by everything inside of by each element inside of the matrix. So it'll be 4 times negative 10, 4 times 14, 4 times 1. That's for the first column. Second column, it will be 4 times 2, 4 times negative 3, and 4 times 0. Our final column will be 4 times 0, 4 times 7, and 4 times 10. So all we're going to do is just simplify, and we will get, so negative 40, 4 times 14 gives us 56, 4 ones 4. For second column, we'll have 4 twos 8, 4 times negative 3 is negative 12, and 4 times 0 is 0. 4 0 is 0, 4 times 7 is 28, and 4 times 10 is 40. So 4B is equal to that matrix. For second example, it says calculate a quarter A when A is 24, 12, 8, and 10. So we have a fraction, and it's the same concept. We're just going to multiply that scalar by each element inside of our matrix. So a quarter A is equal to quarter times the matrix. So I'm going to go ahead and multiply. So it'll be quarter times 24, quarter times 12, quarter times 8, and a quarter times 10. So let's go ahead and write that as one fraction. So a quarter times 24 will give us 24 over 4. That will be 12 over 4, 8 over 4, and 10 over 4. And we can simplify these fractions. So a quarter A is equal to, so 24 divided by 4 will give us 6. 4 into 12 goes 3 times. 4 into 8, 2. And 4 into 10 goes 2.5, or 2.5. So there we go. So the scalar multiplication of quarter A is this matrix right here. And our final question is a combination of the concept of scalar multiplication and addition of matrices. So if you are not so familiar with adding and subtracting matrices, the link to our video is popping up in the top right hand corner at this moment. So let's go. So to work out a problem like this, you first need to work out the scalar multiplication. So we need to find what is 2r, and we also need to find what is 3q, then we will add. So let's go ahead and find out first what is 2r. So 2r is just multiplying 2 by our matrix, which is -5, -8, 3, and 1. So that will give us 2 times -5 is -10, 2 times -8 is -16, 2 times 3 is 6, and 2 ones, 2. Same breath, let's work out what is 3q. So it's 3 times our q matrix, which is 3, 1, -4, and 0. So that's 3 times 3, which is 9. 3 ones, 3. 3 times -4, which is -12. And 3 times 0, which is 0. So we have our... So now we're going to add both of those together. So 2r plus 3q is equal to -10, -16. So there we go. So let's add the corresponding elements. So -10 plus 9, -16 plus 3, 6 plus -12, and 2 plus 0. And that will give us our answer, which is -1. So 10 plus 9 is -1. -16 plus 3 gives us -13. 6 plus -2 will give us -6. And 2 plus 0 is 2. So our final answer is this matrix right here. Thank you for watching. Remember to like, share, and subscribe, and stay tuned for more educational content.